The structure of the atom is fundamental to understanding chemistry. So we're going to take a moment here, pretty brief, to go through the parts and pieces of an atom, but also to give you some insight about isotopes and ions and all the things that you need to know to be successful in chemistry. Let's start here. We need a simple working definition for an atom, and this is the one we use in my class: the smallest matter that has the properties of a chemical element. Basically, if you try to break it up into smaller pieces, well, then it no longer is going to act like that element. So, to the structure of the atom, atoms are made up of three main parts. In the nucleus, which is the center part here, the nucleus is made up of positively charged protons and neutrally charged or uncharged particles called neutrons. Around the outside, we have electrons, and electrons have a negative charge. Now, this is going to be important coming up. That neutrons are actually made of several other particles inside of them. Those other particles have positive parts and negative parts. They're called quarks, but we're not going to go that far in our description right now. You just need to understand that these little neutrons have other things inside of them, and so do protons. Electrons are pretty much their own thing. That's going to take us forward to help us understand the other things that are coming up. There's my disclaimer for that right now, that what we're going to see in a little bit is neutrons can actually break apart into those components and leave things behind, which means atoms can transform into new things. But I'm getting ahead of myself. What is an element then? You're familiar, hopefully, with the periodic table of elements. And here's our definition, a very basic one of what an element is. It is a substance consisting of atoms having the same number of protons in their nuclei. So here's the thing. If you're looking at a periodic table and you see that carbon is number 6, that means that carbon has 6 protons in its nucleus, by definition. Now the other thing, on a periodic table, there are 118 elements, but only 98 of them are naturally occurring. Where do the other ones come from? Well, they've been made. And does that mean that we'll never find them in nature? No, they might exist in nature. They just have not been found yet. The periodic table then is set up according to the elements and how those elements are made. In other words, the 6 there for the carbon is the atomic number. It tells us the number of protons. The mass number for carbon is the mass of the neutrons plus the mass of the protons. It's just the mass of the nucleus. Why is that? Well, electrons are super, super small, and they can move and go away and come and go. So we're really just going to focus on the nucleus when it comes to the math. And interestingly, a proton has a mass of 1. A neutron has a mass of 1. 1 atomic mass unit is what each of those are. So when we dive into the periodic table, we need to understand what all these things are up on the screen, and we'll get into that more down the road. Now, one more important thing. This is another way to write what you're seeing over here. This is actually going to be really useful in chemistry because this is called shorthand form, where we put the mass up here and we put the number of protons, or the overall charge of the nucleus. Now, how would the nucleus have a charge? Because protons are positive, neutrons are neutral. And if we think about this, there are 6 protons in the nucleus and the mass is 12. If there are 6 protons and the overall mass is 12, how many neutrons would there be? There would be 6, because 6 plus 6 is 12. All right. I'm jumping way ahead now. We're going to jump into ions and isotopes because for my high school chemistry class, we're not going to spend a bunch of time dwelling on the structure of an atom. The goal is that that has been learned in past classes. But now we're going to focus on, okay, if we understand the structure of the atom, how can we expand our knowledge and understand how an atom acts? There are 2 key topics here that I want to cover. The first one are ions. This is my disclaimer. Atoms of the same element always have the same number of protons. The number of protons determine which element it is. Carbon always has 6 protons. If I find a carbon and it doesn't have 6 protons, it's not actually carbon. It's something else. It has to have 6 protons, but the number of electrons may vary. In other words, I may be walking down the street and I find a carbon and I count that it has 6 protons and it has 6 electrons. Okay, then I'm walking down the street, I find another carbon that has 6 protons and 7 electrons. Is it still carbon? Yes, because it has 6 protons. But the number of electrons can vary from carbon to carbon, and that's okay. It's just called an ion. So an ion by definition is any atom that has more or less electrons than protons. It does not have an even number of positive protons and negative electrons. All right, now here's the thing. There are two very important ones that you need to remember because they will carry through all of chemistry. A positive ion is a cation. Okay? It has fewer electrons than protons. We're going to walk through this on the next couple of slides. An anion is a negative ion, more electrons than protons. Again, we're going to go through that so you fully understand it, but you do need to remember these. And here's how I remember these and how I teach my students to remember them. Let's look at this. This says cation. Okay, cation is a positive ion. Oh, I remember that because cats have paws. So a cation is a positive ion. Cats have paws. Cation is a positive ion. Maybe that's helpful to you. Maybe it isn't. The other one down here, if I look at anion, that could literally mean a negative ion. Anion, a negative ion. It doesn't mean that, but that's a good way to memorize these. Cation is a positive ion because cats have paws. Meow. Anion is a negative ion. Now, what does it mean to be positive? What does it mean to be negative? For this example, our protons are going to be the greenish color, our electrons will be the gray color, and our neutrons will be yellow or orange, but we don't care about those because we're talking about ions. So how many protons does this have in it? 1, 2, 3, 4, 5, 6. It has 6 protons. They have a positive charge. I'm going to put the positive there just to remember. How many electrons does it have? 1, 2, 3, 4, 5, 6. It has 6 electrons, and electrons have a negative charge. So if we have 6 positive protons and 6 negative electrons, the overall charge is there is no overall charge. This is not an ion of carbon. It's just carbon. Over here we have 1, 2, 3, 4, 5, 6 protons. They have a positive charge. And we have 1, 2, 3, 4, 5, 6, 7, 8. Whoa. We have 8 electrons. So if we sum these together, we have an overall -2 charge. This is carbon. Now, for those of you that know a lot about chemistry, this probably isn't going to happen in the real world, but that's okay. This is carbon in our example with a -2 charge. It has 2 extra electrons. It's still carbon. It's fine. It's happy. It's just negatively charged. It will, consequently, be attracted to things with a positive charge. We'll get to that later. Let's go over here. And if you're wondering, I use carbon in all these examples, even if carbon wouldn't necessarily turn into an ion like this, because carbon is important in science and in biology and biochemistry. So here we go. We count them up. 1, 2, 3, 4, 5, 6. There are 6 protons. That tells me that this is indeed carbon because carbon has 6 protons. There are 1, 2, 3, 4, 5 electrons. The sum of this is 1 plus. Now you can write +1, you can write -5, you can write -6 or +6. Doesn't matter here. Carbon with a 1 plus charge. You could also write this as carbon with a positive charge. And as I just mentioned, you could write this as carbon with a 1 plus charge. All of them are okay. These two are ions of carbon because they have a charge. That's it. And the next really important concept are isotopes. We looked at ions. Now we're going to look at isotopes. Here's my disclaimer. Atoms of the same element always have the same number of protons. So let's go back to carbon. Carbon always has 6 protons. We did find out that the electrons can vary and it can still be carbon. That's fine. But the number of neutrons can also vary. And if the number of neutrons vary, it's called an isotope. So an isotope are where, now this is, I don't love this definition. So when I show you an example on the next slide, I think it'll make more sense. Atoms with the same number of protons, all carbons have 6 protons, but I might have a carbon that does not have 6 neutrons. I might have a carbon that has 7 neutrons, and I might have another carbon that has 8 neutrons. They're all carbons, but they are isotopes of carbon. So let's go through this. We've got our same thing. We're going to count up our protons, we're going to count up our neutrons, and we're going to get the overall mass. Here's another thing. The mass that we're calculating are atomic mass units. They're abbreviated AMU or just the letter U. So we count the protons. They each have a mass of 1. So 1, 2, 3, 4, 5, 6. I can put a plus with those, but we don't really care about the charge for this because we're just counting the number of things in the nucleus. Over here, this has 1, 2, 3, 4, 5, 6 neutrons. They don't have a charge, so I'm just going to write it as a 6. To find the mass, we add the protons with the neutrons. So this has a mass of 12. When we write this out, we would say this is called carbon 12. It is the atom carbon. It has an overall mass of 12 atomic mass units, which can be abbreviated with a U. Now let's go to the next one, because this is normal everyday carbon. If we come over here, this one has, we count the protons, 1, 2, 3, 4, 5, 6, 6 protons, and we count up the neutrons, 1, 2, 3, 4, 5, 6, 7. It has 7 neutrons, which don't have a charge, so I won't put anything there. If I add these together, I get 13. Now you should be figuring out at this point, this is carbon. This carbon has a mass of 13, so this is carbon 13. This is an isotope of carbon. It is not normal everyday carbon like this one was. This has a different number of neutrons. It has a mass of 13. Now, how do I know that this is everyday normal? I'm going to show you that. We're going to get there. Just bear with me. I'm telling you that is normal, happy, everyday carbon. This is an isotope of carbon. Let's go to this one. 1, 2, 3, 4, 5, 6 protons. Count up the neutrons. 1, 2, 3, 4, 5, 6, 7, 8 neutrons. We add these together and we get 14. You guessed it. This is carbon 14. Now, you should be figuring this out. This is also an isotope of carbon, because if this is regular old carbon and this was an isotope of carbon, this is also an isotope. Could there be carbon 15? Perhaps. Could there be carbon 16? Perhaps. So it's still carbon, but the isotopes of carbon. Now, why do we care about isotopes? Because isotopes, in most cases, are radioactive. And this brings up a good question. Now, if the mass of a proton is 1 atomic mass unit, and the mass of a neutron is 1 atomic mass unit, and to get the mass, we just add up the number of protons and the number of neutrons, shouldn't it always be a whole number? For example, if I had 2 protons and 2 neutrons, it would be 4. Okay? But let's look at this periodic table. Almost all the masses are not nice round whole numbers. Even carbon here has a mass of 12.0107. At this point, people oftentimes say, oh, that's the mass of the electrons. No, it's not. The mass of the electrons is not included. Electrons have a mass about 1/2000th the mass of a proton. So we just don't include them for the reasons I mentioned earlier as well. So what's going on here? Well, this number is calculated in an interesting way. Let's say we took you and all your friends and I had you go out and everybody's going to find a carbon. All right? And that carbon, I'm just using my little squishy globe here. That carbon, we're going to have you bring them back and we're going to count how many protons and neutrons are in that carbon. So somebody brings one back and we find out, oh, look, there are 6 protons and 6 neutrons. This is carbon 12. This carbon has a mass of 12. Then the next person comes in, they're like, oh, I found a carbon as well. And we count up how many protons and how many neutrons, and we see, oh, look, this is carbon 12. And then we have everybody else coming back in, and they're bringing us in carbons. And what we're finding out is just about every one of them is carbon 12. But we know that maybe carbon isn't always carbon with a mass of 12. In fact, somebody brings one in, and we're like, whoa, your carbon is different. It has 6 protons, but look, it has 7 neutrons. So that carbon has a mass of 13. Now think about this. Mathematically, if we add up the mass of every one of the carbons that we brought in, including the one that had a mass of 13, we're going to get some math like this. 12 plus 12 plus 12 plus 12 plus 12 plus 12 plus 14, if I said the correct number of those. And if I take those and add them all up, that's 98. All right? So 98 divided by 8, because we have 1, 2, 3, 4, 5, 6, 7, 8 that we found and brought in, we get 12.25. Here's what this means. If every carbon ever studied were just these 8 that we brought in and tested, the periodic table would say that the mass of carbon is 12.25 U, or AMU. It doesn't. It says the mass is 12.0107. So that's because there's been a lot more carbons that have been tested and analyzed than 8. There have been who knows how many, a lot. And what we find out when we average the mass of all the carbons that have ever been studied is that we get a mass, or an average mass, of 12.0107. So the number on the periodic table is actually the average of all the masses of all of the elements that have been studied. And that's why it's not a whole number. Now, how do I know that carbon-12 is the most common one? Well, conceptually here, if I round this to a whole number, then it would be 12, which means carbon, and this is just kind of a trick way to do it, that means that carbon with a mass of 12 is the most common one because this number is closest to 12. That doesn't always work for really big elements, but we can discuss those later on. For now, what we need to do is just say, okay, if I really want to know the mass of the most common type of carbon or the most common of any element on the periodic table, I look at the mass on the periodic table. The nearest whole number will tell me the most common form of that element. And that's brief, but that's really the basics of what you need to have. You need to understand what an atom is made of. And then if you can remember what ions are and you can remember what isotopes are, we can build on that throughout all of chemistry and really build our understanding of what an atom is, what it acts like, and what it does. And we'll get there. Now, the next place I'm going to go with this is radiation and radioactive decay. Why? Because if you understand radiation and radioactive decay, you can understand how an atom works and what it's like. So that's the next stop. Then after that one, we're going to move our way out to the electrons. We're going to learn what the electrons are doing and why they're so fascinating. I appreciate you watching. I appreciate you learning. And I want to remind you, as always, to keep on learning.